In this video, I'm going to do a quick review over the EMR spectrum that we went over in class. Remember, it stands for electromagnetic radiation spectrum, and we drew a picture that looked like this. Started out big, and then as you got to this side, whoops, it did not do that. And then it got smaller and smaller over here. And we labeled these things. We labeled them, you have radio, then microwave, infrared, you have your visible light that we see as colors, UV, X-rays, and gamma. We talked about how there's a deciding line in between visible and UV, between non-dangerous and dangerous. UVs come from the sun, they can cause skin cancer. X-rays, when you have X-rays, you have to wear that lead plate to keep the rest of your body safe. And then gamma rays are used in cancer treatment, but are also given off from like nuclear power plant meltdowns it's extremely dangerous. So we labeled some things, and we talked about the relationship between the wavelength, which is one peak to another, and frequency and energy. So remember that this is wavelength. And then the height of it is called amplitude. So these are very important vocab terms that you need to make sure that you know. We talked about how on the radio side of the spectrum, it has low energy. This is why radio, microwave, infrared, visible are not dangerous, because it has low energy. But as you go to the right on this and you get to gamma rays, you encounter ones with high energy. That high energy is what is so dangerous. We talked about how on the radio side right here, that the waves are not going up and down very often. This is called frequency. So this means it has a low frequency. It's a vocab term, make sure you know it. Frequency is how often the wave goes up and down in a given amount of time. As you go to the gamma side, you get high frequency. Okay, now let's talk wavelength. So again, your wavelength is from the height of one wave to the top of the other wave. That's the wavelength. So right here, that I'm outlining in green, is a very long wavelength, whereas over here by gamma, that's a very short wavelength. So on the left side with radio, it's a long wavelength, and then over here is a short wavelength. So you'll have to be familiar with that relationship, and you'll have to be able to tell me that as energy increases from left to right, your frequency also increases. That is called a direct relationship. So as energy goes up, frequency goes up. That's a direct relationship. Now, energy increases from left to right, but wavelength decreases. It gets shorter from left to right. So if energy increases and wavelength decreases, this is called an inverse relationship. My writing's not showing up all that well, but you can listen and write it down as well. So those are just two relationships that you need to know. We talked about the colors of the rainbow being Roy G. Biv, and it's in that order for a very specific reason, because R is closer to the radio side. I like to say R goes with R, which means out of these colors, red has the lowest energy, lowest frequency, and longest wavelength. That's actually why it's easier to see. Whereas violet is closer to this gamma side, which means it has the highest energy in the colors, the highest frequency, and the shortest wavelength. That's your EMR review. I'm out.